Okay, hi everyone. This is a video for Math 105, and it's for section 1.5, and I'm going to do a derivation of the quadratic formula. In some sense, this is a culmination of intermediate algebra, the prereq for this class. But it's, as I said, chapter 1 is kind of including a lot of stuff from Math 104. Okay, so the statement is if ax squared plus bx plus c equals 0, and this is where a, b, and c are real numbers, and a is not 0, then x, you can solve for x, and x is minus b plus or minus the square root of the quantity b squared minus 4ac all over 2a. Okay, notice you're dividing by 2a, so it makes sense that a can't be 0. Okay, so how do you actually solve this? Is by using that complete the square method. So let ax squared plus bx plus c equals 0. First thing we're going to do is divide everything through by a, so that the coefficient in front of the x squared becomes 1. So if I divide everything by a, then in this case the a's cancel, and I get x squared plus b over ax plus c over a, and it still equals 0 because 0 divided by a is just 0. Okay, now I'm going to subtract the constant term from both sides. So x squared plus b over ax is going to equal negative c over a. And I'm going to leave some room because I need to add something here, right? To complete the square, you've got to add the same thing to both sides. That completes it. And what do you have to add? Well, you take the middle coefficient, the coefficient on the x term, you divide it in half and square it. So actually what I have to add is b over 2a squared. And again, I have to put it in both. Well, what is that? That winds up being b squared over 4a squared. Okay, so if I do that, I get x squared plus b over ax plus b squared over 4a squared equals b squared over 4a squared minus c over a. Again, the reason we do that is now this thing's a perfect square. So if you factored this, you'd say, oh, this is actually x plus b over 2a quantity squared. And so that's going to equal b squared over 4a squared minus c over a. Now we're set up to solve by taking square roots. I've got an expression squared equals, this is ugly, but it's just some number. Maybe before I do that, let's get a common denominator on this side. So I've got a and I've got 4a squared. So I need a factor of 4 and I need another factor of a here to get a common denominator. So if I leave this way, and here I get a common denominator, the common denominator is going to be 4a squared. So I don't have to do anything here. And here I need the 4 and the a, 4ac. That should be looking quite familiar at this point. Okay, so now I'm gonna move it up here, but what I'm gonna do is take square roots. So if I take the square root of this side, I just have x plus b over 2a. And if I take the square root of the other side, I have plus or minus the square root b squared minus 4ac and 4a squared. Okay, at this point, there's kind of two things left to do. I need to take this term and move it to the other side, and then simplify this if I can. So let's move it over. So it's plus b over 2a, so it's going to be minus b over 2a, plus or minus. And let's split the, if you have the square root of a quotient, that's the quotient of the square roots. So I can do this. Okay. Now, believe it or not, this thing simplifies. It actually, the square root of 4 is 2, and the square root of a squared, well, the square root of a squared is technically the absolute value of a, but that's either a or minus a, and they're both covered here because I got a plus or minus. So because of this plus or minus, I don't need the absolute value. I can just make it 2a. So that's kind of something that's often overlooked if you see these derivations on the web. But technically, again, it should be square root of 2 times the absolute value of a. But I've got plus or minus the absolute value of a. That's going to give me the same answers as just plus or minus a. And now I have a common denominator, so I can add those two fractions and just make it one denominator for the whole thing. And we're done. Look at that. So pretty cool. If you start out with ax squared plus bx plus c and kind of go through it like you're completing a square, but instead of having particular numbers for a, b, and c, you just leave them as a, b, and c, what you get at the end is the quadratic formula. Pretty cool. That's it. I hope this is interesting.